In this video, we're going to be looking for the proof as to why there is a right angle when a chord is bisected by a radius. Okay, so if you don't know what bisect means cut in half. So this is what we call an if and only if proof, which means that we need to prove it both ways. So first of all, we're going to assume that the radius is perpendicular to the chord. If you want to get a copy of my super nice neat notes, then head on over to my website. We're going to start this proof by assuming that there's a right angle here. Now, we know that this radius has to be the same length as this radius, and that here we've got a right angle. Now, it also makes sense that this distance here is the same because it's a common line, it's shared by them. But now we have the situation where we have two sides the same in the triangle, another side the same, and an angle the same. So these two triangles are congruent. And congruent means, we've talked about this before, but basically if you were to copy them and sit them next to side by side, they would look exactly the same. So this length has to be the same as this length here because they're congruent triangles, they're exactly the same. So that means that if this is the full length, this must be exactly the middle point because one side can't be longer than the other side, so this can't be longer than this because we know that they're the same length. Okay, so that's the first way around the proof goes. We assume that there's a right angle and we prove that the chord is bisected, the chord is cut in half, or that this length is the same as that length. Now, we're going to do the proof the other way around. We're going to prove that if the radius is bisected, so the radius is cut in half, there must be a right angle. So you can go both ways. You prove bisected implies right angle and right angle implies bisected. So we start with a triangle that looks like this. We know that this length is the same as this length because they're both radii. We know because it's an isosceles triangle, right, that this is the same as this, that these two angles must be the same. Now, this length has to be the same as this length because that's what we've assumed. We've assumed that this chord is cut in half, and if it's cut in half, this has to be the same as that. So now we can see that these two triangles are congruent, okay, which means all the angles are the same. So this angle here must be the same as this angle here, right? But we know that these two angles here are on a straight line. A straight line has 180 degrees. So 180 degrees would be equal to 2x, one x here and another x there. And if you divide 180 degrees by 2, that gives you 90. So each x must be 90. So now we've proved that if the chord is cut in half, then the angle here must be 90. So that concludes our proof. We proved it both way rounds. Starting with a 90, we got it bisected, and starting with bisected, we got a 90. So in the next video, we're going to be looking at how we can apply this to exam style questions.